Topic 9-5, referenced with our Holt textbook, page 590 through 591, in chapters 9, but also in chapter 6, section 6, on page 431. Okay, we're dealing with the area and perimeter of trapezoids. So I went ahead and did my snap legs to show two types that you can encounter. Trapezoids can either be a right trapezoid or an isosceles trapezoid, or even one that doesn't have any of those properties. But the main thing is it's a quadrilateral with exactly one pair of parallel sides. This would be your parallel side, and this would be a parallel side, also called your two bases. Their two bases are parallel. So that would be this purple and this blue. For the isosceles trapezoid, you're going to have two bases that are parallel. That would be the yellow and the red being parallel. And if this angle measurement matches this angle measurement, then these two sides represented with the orange would be congruent to one another. And so that's called an isosceles trapezoid. So we're going to derive the formula for area by using the extra page that you have that looks like this. It came with your topic. And what they're telling you is to fold it along this line and this line and cut these. It'll end up cutting these out together. It doesn't matter if you do it that way or not, but you're going to take these papers and cut through both thicknesses if you want to, or cut them individually. And then once you get your two pieces, turn one way and turn the other way and tape them onto your topic page. What we're trying to represent is two trapezoids. The figure that they make when you put two of them together is what figure? A parallelogram. So you can calculate the area of a parallelogram by using the base times the height. So knowing that we have base and height measurements, that says how does the area of the parallelogram and the original trapezoid compare? So if you were looking at just one trapezoid, we know that it's half of the area of a parallelogram. So for the formula of a parallelogram using base times height, this is how you derive the trapezoid area formula. Your base, you actually have two of them. So you're going to have to add those two together before you multiply it by the height, and then take half of it. So you can show it in the area of a trapezoid is half of the height multiplied by the two bases added together. And notice the base 1, base 2 is the parallel lines, can either be upside down, doesn't matter. Okay, so area of a trapezoid is half of its height multiplied by the two bases added together, and the perimeter is simply adding up all the sides. Okay, so we're going to do a few examples. They've given you a base of 8 and 12 and a height of 7. So using the formula and just plugging in, you've got 7 times, that's why we have parentheses, the addition of 12 and 8 and divided by 2. And that's going to give you 70. So take a minute and fill in your base measurements, and this is just saying units. 8 units, 12 units. Area is always in square units. Okay, here's one that we had to do a few things before we could calculate the area. Because the base wasn't given, the height wasn't given to you, you would want to show a dotted line to form the altitude or height and make a perpendicular line. So to derive 4 square roots of 3, we had to remember that that was our special right triangle of 60, 90, this little measurement being 30. Across from our 60 has a value of x square root of 3, while our x is 4. Again, if you need to refer to your reference chart, second page at the bottom, it will show you a 30, 60, 90 at the bottom of the reference page, this one right here. So knowing that the x represents the 4, the x square root of 3 would represent this line here, the long leg, that's opposite the 60-degree angle. So 4 square roots of 3 is my height. The trapezoid base, you have to realize it's this whole distance here to here. Well, by drawing two altitudes, the distance here is 12 because it's the same as this distance. This distance being 4. Oh, 4 wasn't given to us. We had to take half of 8 to get 4. 2 of this number. So if that number was 8, then this would be 4. The reason we know that this distance here and this distance here are both 4 is because it's showing to be an isosceles trapezoid, both of these being equal. So doing the math, you're multiplying by radicals, so be careful that you have to multiply the 4 times what, 32? Yeah, 32, and then keep your square root of 3 separate from it. But once you multiply the 4 times 32 and divide by 2, you'll get 64. So 64 square roots of 3 is our area, and the perimeter you would be walking around. This is a 20. If this is 8, then this is 8, and this is 12. Add up all of those and you get 48. Okay, if this is 3, this is 3. If this is a 45, then that means this is 45 degrees. So therefore we know this is also 3. But knowing if this is 4, that base is 4, this would be a total of 7. Take a minute to digest all of that. They did give you 3 here, so that's another way we could have realized that both of these were 3. But knowing this side was 3, this is also 3. Plug in the formula, your two bases added together, multiplied by the height, divided by 2, would leave us with 16.5. When you're calculating the perimeter, be really careful that you add 7, 3, and 4 together to get 14, but 3 square roots of 2 has to stay separate because of the radical. So the unit measure, this is all again in unit measures. Okay, moving on. Recall that a median is the segment joining the midpoint of the legs. If you want further explanation of this, refer to page 431 in your textbook. They actually call this, instead of the median, they call it the mid-segment. So we'll put median or mid-segment. Oops. Couldn't spell. Mid-segment. Alright, so if you took a piece of patty paper, you've been shown that if it is the median being because these two are equal to each other and those two are equal to each other, if you took this line here, the addition of base 1, we'll call this base 1 and this base 2, and I drew this line and I'm going to add this line to it with my patty paper. What they're telling equal to half of those two added together. Well, if I take that line, this line right here, and find out the halfway mark just by folding it, you will see that this halfway should be my measurement of the median in this, there it is. So if you want to just ingrain this in your mind, take a piece of patty paper and test out that theorem, because you're going to be using it to answer the following examples. So an alternate way to find the area of a trapezoid is to find the product of the median and the height, or the median times the height. So the area given here, if they've given us the height and they gave us a median, and we only know it's a median because of these tick marks. If those tick marks aren't there, you wouldn't be able to use this formula. And so that's just 8 times 8, which is 64 units squared. A trapezoid has an area of 7 centimeters and a height of 5. How long is its median? Well, if it was just to multiply the median times the height and they gave us the total answer, that's just division. You're dividing the total by the height of it. So the median would be 7/5 centimeters. Oh, then that is it for 9-5.